On question 13, it's asking us to find all points of inflection for the graph of y equals e to the power of negative x squared. Let's remember that a point of inflection comes from the way we find it, I should say, comes from the second derivative graph. If you look at our little chart up here, it says a possible point of inflection comes from the second derivative graph, only if it changes sign. So we're going to be looking for the zeros of the second derivative that change from positive to negative or vice versa from negative to positive. So we have to find the second derivative of this first, yeah. It's not that you can't find them, but if you were going to find them, they would be the maxima and minima of the first derivative. And we don't know how to find the maxima and minima of the first derivative unless we find the second derivative. So from a graph, yes. From a graph, I would say you could find them. But from an equation, I would say it's not the best idea because you have to go and find the second derivative anyway. All right. Sorry, I'm waiting for my iPad to connect. All right, here we go. So if we're going to use the chain rule, and again, my hope is that some of you guys would start to use the chain rule in your heads and not necessarily have to write it out on paper. If you're not there yet, it's okay. Go ahead and write your U and your V. If you are there, however, go ahead and try to do it in your head. All right, let's check your answer for the first derivative. What did you guys set your U equal to? Negative x squared, good. And what was the derivative of negative x squared? Negative 2x, perfect. So the derivative for this function is going to start with negative 2x because that's the derivative of the inside. And then what did you set your u equal to? Or sorry, your v, excuse me. E to the u. And what's the derivative of e to the u? It's itself, good. E to the u again, which is e to the negative x squared. So multiply the derivative of the outside and the derivative of the inside together. E to the negative x squared, and that's what you get for the derivative of the chain rule. Now, when we take the derivative again, what rule do we have to use now? Product rule and chain rule. So, again, if you can do it in your head, that's great. I'll write it out for you guys just to make sure we're all on the same page, though. If I set up the product rule, I have my u and my v. My first function is negative 2x. My second function is e to the negative x squared. Now, v prime is going to be easier for us. Why is v prime going to be easier for us? We just found the derivative of e to the negative x squared. So what we just got for our answer over here as negative 2x e to the negative x squared, we're going to write as our answer for v prime. So negative 2x e to the negative x squared, that's v prime. How about u prime? What's the derivative of negative 2x? Negative 2, awesome. Product rule says we're going to multiply. I'm going to multiply u prime and v first. So if I multiply those two, I get negative 2 e to the negative x squared. So I'm going to write that right here. Y double prime equals negative 2 e to the negative x squared. And then if I multiply forwards, I get negative 2x times negative 2x e to the negative x squared, which, if you guys are okay with me simplifying right now, is a positive 4x squared times e to the negative x squared. Positive 4, because negative 2 times negative 2 is positive 4. X times x gives me x squared, and then e to the negative x squared. All right, that is the second derivative, fully simplified using the product rule. Now, to find points of inflection, remember, we need to know where the second derivative equals 0 and changes sign. It has to change sign. So I need to know where this function is equal to 0. That will tell me where the original function has a point of inflection as long as it changes sign. All right, do you know how to solve that equation? Okay. You will in just a second. It's not as hard as you might think. Any ideas? Yeah, what about that? Yeah, do you guys notice that both of the terms in this equation have an e to the negative x squared in them? All right, we call that a GCF. If multiple terms have the same number in them, or the same term, we can factor that out as a GCF. So I want you guys to rewrite this, factoring out the e to the negative x squared. And then whatever's left over, leave inside parentheses. So for the first term, when we take out e to the negative x squared, we're left with negative 2. For the second term, when we take out e to the negative x squared, we're left with 4x squared. Now, the reason we do that is because we can use the zero product property. If we are able to factor this, we can set each of the factors equal to 0 and use the zero product property in order to solve them. So for the first one, if I set e to the negative x squared equal to 0, and then for the second factor, I can set negative 2 plus 4x squared equal to 0. And we can solve these two equations separately, and we'll get all the values of x that will make this function equal 0. Let's start with e to the negative x squared. What value will make e to the negative x squared equal 0? Yeah. 1?
No.
Say it again. That's right. There is no exponent that makes something equal 0. I can't plug anything into this to make this equal 0. E to anything will always be a number other than 0 because an exponential function has an asymptote at 0. It never actually equals 0. So there is nothing I can plug into this that makes it equal 0. Another way you could know that, by the way, to actually solve this equation algebraically, if you take the natural log of both sides, remember that the natural log of e, those two are inverses of each other. So to get the negative x squared out of the exponent, this is how we would do it. But what do you guys know about the natural log of 0 over here on the right-hand side of that equation? What is the natural log of 0? It doesn't exist. It's undefined. There's a vertical asymptote on the natural log graph at 0. So that part of the function has no relevance to our answers. There will be no answers that come from that part of the equation. So that means that the only answers we're going to get are from this other half of the equation, the negative 2 plus 4x squared equals 0. Do me a favor. Go ahead and solve that right now. Solve for x. Add the 2 over, divide by 4. Take the square root of both sides. You should get plus or minus the square root of 1/2. It's okay if it's not rationalized. I don't need you guys to rationalize that. You can leave it like that. My question for you is, does the graph cross through the x-axis at both of those points? And how do you know? Yeah, okay. Do you know what type of equation this is? Negative 2 plus 4x squared. Do you know what it looks like? It's a parabola. So if it has intercepts at plus or minus the square root of 1/2 and it's a parabola, that means it's definitely going to cross through the x-axis because that's what a parabola looks like. So yes, it will cross through the x-axis at both of those points. Therefore, these are our 2 points of inflection. This is our answer down here at the bottom. To solve for all points of inflection, we have to find the second derivative, set it equal to 0 to find the critical points. This is a little trick that we're going to use multiple times this year where we take out a GCF of e to the something or whatever and then solve whatever's left over. And as long as we know that it crosses through the x-axis, we can guarantee that those are points of inflection. So on the original graph, at positive and negative radical 1/2, we would have a change in concavity. From concave up, since the second derivative is positive, to concave down at negative 1/2, radical 1/2. And then from concave down to concave up at positive radical 1/2. All right, let's look at 13. Number 13 says, let f be a polynomial function with the values of the derivative at selected values of x given in the table above. Which of the following must be true for the interval from negative 2 to 6? Do me a favor. Can you guys really quickly plot those 5 points? Draw an xy plane and plot them on your graph. All right, when you're done, it should look something like this. This is what I got at least. It doesn't have to be super, super accurate, but as long as it looks something like that. All right, it says, which of the following must be true for the interval from negative 2 to 6 if this is a graph of the first derivative? These are points on the first derivative. Now, it's not necessary to graph this. I think it's helpful to graph it since these are notes and it's helpful to visualize what the graph actually looks like. But if you could look at the table and answer this question, that's totally fine. You don't have to show work in order to answer it since it's a multiple choice question. All right, So remember, this is a graph of the first derivative. Can you imagine what this graph might look like if we connected these points together? All right, you don't necessarily need to, because the way you connect them might not be the exact way that they are connected. So you can kind of visualize what it would look like, and we're going to gain what we definitely know about this function based on this graph. So the first one, it says, the graph of f is concave up. Well, if we look at our chart, if f is concave up, what do we know about its first derivative? It's increasing. If you connected these points, even in the most basic way, it would look like this. This is the most basic way to connect these points. Is that function always increasing? No. So therefore, we cannot guarantee that the graph of f is concave up because it has to decrease at some points based on the points that are given to us. So A is definitely not a true statement. The second one says the graph of f has at least 2 points of inflection. So let's go to our chart. If f has a point of inflection, what am I looking for on the first derivative? A max or a min. Does this graph have at least 2 maxima and minima? Yes, it has at least 2. I drew it in the simplest way possible, and it had to have at least 2. So I'm going to go ahead and say that's a strong contender, that it has at least 2. Unless we get another one that we can convince ourselves might be an answer, I'm going with that one. C. C says f is increasing. So we go to our chart. Wherever f is increasing, what do I know about its derivative? It's positive. Is this graph always positive? The way that I drew it, it is. Is this the only way you can draw it? No. What if I drew it like this instead? Let's see if I can erase this without actually erasing the entire thing. What if I drew it like this? Could it be drawn like that? Yeah, and that graph is not always positive. So the way I drew it first, sure, it was always positive. But if I draw it like this, the answer would be no, it's not. Therefore, f is not guaranteed to be increasing. It could. I'm not saying it's not. But it's not guaranteed to be increasing if it goes below the x-axis. So C is not a correct answer. D says f has no critical points. Remember that a critical point, which is a maximum or a minimum on the graph, a critical point would be wherever the derivative is equal to 0. The way that I just drew the graph, does the derivative equal 0? It could, right? If I drew it like this, the derivative would be equal to 0 2 times. The first way I drew it, maybe it wasn't. But again, it's not guaranteed. You don't know for sure if the derivative has no critical points unless you know if it goes through the x-axis or not. E. E says that f has at least 2 relative extrema. Again, relative extrema, maxima and minima would be zeros on the derivative, and no, it could or it could not. We don't know how it's graphed or whether or not it goes through the x-axis, so we can't state whether or not it has at least 2 relative extrema. So keep that in mind as well. By the way, that last one, you know how we always talk about endpoints as being relative extrema? Notice that the endpoints are not included. It's just less than. It's not less than or equal to, so that's why don't get the endpoints confused in there with that one because of that. So E is not a good contender either, since we don't know if it goes through the x-axis or not. All right, with all that said, I think B is our go-to answer for this. We can safely say that the graph has 2 points of inflection. We know that, by the way, if you didn't actually want to graph it, if you just wanted to look at the table, notice the y values. To get from 3 to 1, we have to go down. To get from 1 to 4, we have to go back up. So there had to be a minimum at some point in there. From 4 to 7, you go up, and then from 7 to 5, you're going back down again. So there had to be a maximum at some point in there. So there definitely had to be 2 maxima and minima, which indicates at least 2 points of inflection on the original function. All right, last but not least, I want to do number 15. You guys got your graphing calculators? Get them out. Enter that equation in for y equals. So for my y equals, I'm going to enter in e to the power of x to the 4th minus 2x squared plus 1, and then minus 2 on the outside. Now, for your viewing window, be careful about what viewing window you choose, because notice that the problem says they only want to know from negative 1.5 to positive 1.5. If you have your viewing window wider than that, it's going to give you way too much information. And also, sometimes it takes a long time for the calculator to graph it, so you could be wasting time. Like once you realize you have too much information, you have to wait for the calculator to finish graphing it before you can go back and change the window. So try to be conscious of what window to use before you graph it. So we're going to go to window, and I'm going to put negative 1.5 to positive 1.5. And then for the y min and y max, we can keep it as negative 10 to positive 10 for now. If we need to come back later and fix that, we can fix that. So here's what my graph looks like. I don't think that's a very good picture of the graph. I like to see it in its largest scale. So I think I have too much information on the y-axis. I'm going to cut it down from -5 to +5. It's not that you can't look at it from that other perspective, but I really like to get my graph inside of my window in a way that I can see the whole thing in its entirety. So that's better. I might even say I would want to zoom in more depending on how much you want to see, but I think that's plenty for right now. So let's go ahead and see what this question is asking us. It says, given this equation, over which intervals will the function f be concave down? So I want to know where the function is concave down. Which function are they giving us? What, this e to the power of x to the fourth minus da 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 da, which function is that? F prime. It's the first derivative. So remember that. I want to know information about f. They're giving me f prime. So to find out information about f, I go to my chart and I look at the first row. If I want to know where it's concave down, I go all the way to the end of the chart. What am I looking for on the first derivative then? Where it's decreasing. Remember that concave down means the slopes are decreasing. So if that means where slopes are decreasing, we're looking for where the derivative is decreasing. Can you guys see where it's decreasing? From -1.5, we know this endpoint is -1.5. From -1.5 to right here, whatever that point is. And then again from what? From 0, this is at 0, all the way over to whatever this value is. Now, those look kind of like they're at -1 and +1. Are we guaranteed that they're at -1 and +1? No. So how do we figure that out? Say it again. I don't want to use trace because remember trace only gets me a little accurate. It's not perfect. Second calc, yeah. So it depends kind of what section of the AP test you're working on. If this is a multiple choice question, which this one would be, if this is a multiple choice question, it's fine with them if you use second calc to find maxima and minima. But on a free response question, they do not want you using second calc to find maxima and minima. So in that case, you'd have to actually find the derivative of that using the chain rule. I know it looks like a beast, but it's actually not that hard of a problem to take the derivative of. You'd have to take the derivative of that using the chain rule and then find the zeros. We'd have to find the zeros so we could figure out where it was negative versus positive. But since it's a multiple choice question, they will have no idea what you're doing. So it's okay if you use second calc to find a maxima or a minima. So let's do that. Push second calc. The first one was a minimum, so I'm going to push option 3 to find that minimum. Now, I think that that's about at -1. So a number that's to the left. Notice these questions. They're asking you three questions down here. The first one is a left bound. What's a number that's definitely less than -1? How about negative? I don't know if they'll let me put -2. Let me see if they'll let me put -2. Nope, they don't like it because it's not on my screen. Let me try something else. Second calc, min. Let's try -1.5. I think you have to choose numbers that are in your viewing window. So -1.5. All right. What's a number that's definitely to the right of -1? 0. So my right bound is 0, and then they want me to guess. I'm going to guess -1. And look at that. It was exactly at -1. Why don't you guys go ahead and find the other minimum over here, and then find the maximum right here. We'll see if they're all at 1 and -1. We might get lucky. Even if you already know that they are, just practice finding the maxes and mins. Yeah? Again, the reason why we're trying to find the maxima and minima is because I want to know what interval, oops, that's way too big. This highlighted orange region right here, I want to know what interval that is. And then this highlighted orange region right here, I also want to know what interval this is. So in order to find those intervals, I need to know what these maxima and minima are so I know where my interval's boundaries are. So for this first one, it's from -1.5 to -1. So we're going to write over here -1.5 to -1, comma -1, union, and then it picks up again at 0 and stops at 1. So these are the two intervals where f prime is decreasing. Therefore, the original function will be concave down since its slopes are decreasing. Now, the nice thing about this being on a multiple choice test, this specific question, is that the answers would all be there for you in terms of, like, you can sometimes just use, like, if you can get a picture of what the graph looks like and you're like, that's pretty much -1, that's pretty much 0, that's pretty much 1, you can use the answers to figure out which answer choice matches up without actually having to calculate maxima and minima. So keep that in mind, is that on a multiple choice test, you probably wouldn't even have to go through that process of calculating them. All right, any other questions on this worksheet? Perfect. So then here's what we're going to do today. You guys have a homework assignment tonight, and I've already uploaded it on School Loop. I want you guys to start on it now because it's not like it's a ton of questions, but it is enough that you guys are going to be busy with it for a while. I won't collect it for a bit. I'm probably not even going to collect it till after the AP test. I'm sorry, not after the AP test. Awkward. After Thanksgiving break. That would be a long way away. After Thanksgiving break, so you do have some time, but I don't want you to push it off because I want to give at least some kind of an assessment. I might not give a test for Unit 5, but I want to at least give a quiz because it's very important to me to know how you're doing on function analysis before the day of the final. I don't want that to be the first time I test you on function analysis because I want to make sure that you guys know what you're doing. So you will have some kind of a quiz or quest or test on Unit 5. And the faster you know how to do this stuff, the better you'll become at it because you just need practice doing it on your own in order to know how to find your misconceptions. So all of that to say, if you want to grab a Chromebook, go ahead and log on to School Loop and look at your homework for tonight. Or if you want to grab it on your phone, you can do that as well. But please get started. I don't want you working on anything else in class right now.